which is very interesting. Okay, so let us see what are the key contents of this sixth unit. Okay, so the name of the sixth unit is Fundamentals of Acoustics. Okay, so in that we will be looking various important parameters. The first parameter is studio acoustics and reverberation. Okay, the second point is PA system for auditorium. Okay, so PA stands for public address system. Okay, so what could be the requirements? Okay, how the setup is done for a specific auditorium, that we'll see. Okay, then the third point is acoustic chambers. Okay, how the acoustic chambers are designed for a particular purpose. Okay, taking the consideration that the attendees, okay, who are following the program will be in a position to listen the sound from the source in a very convenient manner, right? Okay, the fourth one is cordless microphone system. So generally we use cordless microphone system. So we will be looking at what are the key constituents of this cordless microphone system, and what is the principle of working, what kind of technology is used, and how it works. Okay, so we will be looking into that one, because as far as our sixth unit is concerned, there are I guess two lab assignments are there. Okay, so it is very interesting and important to know how the things work which we use them on a daily basis. Okay, so for most of the times we used to attend the various lectures, seminars, okay, in conference hall as well as the Gadima auditorium. Am I right? So in that, at that time you are just a listener, right? So you just sit and listen. But what is the, the requirement, the complete requirement, the design, okay, the principles, okay, the execution of all the sound related things, okay, that we must know, so that we could be able to concentrate on those points for which we are going to design a system. As far as acoustics are concerned, it is not just the what we can say, arrangement of various equipments, connecting the various equipments, but also you need to take care of how the sound is traveling within that particular region. Okay, whether proper absorption is there, okay, taking care of echoes, taking care of reverberation, and so many things are involved in that. Okay, so the consideration and designing, okay, is the important aspect of this unit. Okay, so the next point is special types of microphones and speakers. Okay, so here we are uh, mainly emphasizing on which type of microphone is used for what kind of purpose. In the similar context, what type of speaker is used for what kind of purpose, that one should take care of, because optimization is one of the important aspect for this purpose, right? So you must use the instrument as per their functionality and as per your requirements. Am I right? Okay, and the last two important points are digital radio receiver and satellite radio reception. Okay, so these are the constituents of the sixth unit. Okay, so today we will be looking at the fundamental part, the fundamental concept of acoustics, Then what do you mean by reverberation? Okay, most of you know what is reverberation, but here we will see the definition along with some calculations. Okay, and how we will see how important is the reverberation is, right? Okay, and after that we will be focusing on absorption coefficient, okay, and various parameters. We will take 2 3 problems so that concept will be clear for you to understand in what direction we are going. Okay, understood? Okay, so let us start with the fundamentals. Okay, so let me write down the first point: fundamentals of acoustics. Fundamentals of acoustics. Okay, so acoustic means what? You are basically dealing with the sound. Am I right? Okay, so there are various definitions. Out of that we will be focusing on the uh, most accepted definitions. Okay, so basically it is a science of what? Sound. It is a science of sound which includes the production, transmission and effects, including biological and psychological effect of sound. Okay, so what did they say? It is including the production plus transmission, okay, and the effects, considering what? Biological and psychological effects. Okay, so basically if you want to uh, arrange, or if you want to produce a concert, at that time the production of sound, okay, the sound production by means of various sources, okay, then the transmission of that sound, okay, so various instruments are playing, right? Instruments are there, then vocals, okay, so all the things are mixed together and transmitted to the speaker system, okay, properly arranged speaker system, so that the listeners could get the feel of the mixing of this particular band. Am I right? Okay, so the transmission to the speakers along with the effects, okay, so effects are also important. So basically it is the science of sound which includes production, transmission and effects, including biological and psychological effects. Okay, acoustics is also defined to those quality of a room which collectively determines its character with respect to auditory effects. So basically what we can say is that it is the basic concept of designing of sound, its transmission, right, along with the effects. So these things are very very important as far as the definition is concerned. Am I right? So, in this, the concept of acoustics and reverberation, okay, we will be discussing along with some important definitions. Okay, so the construction, characteristics, and applications of various types of microphones and loudspeakers has been included in this one. Okay, because what we are saying is the source is generating some kind of sound that has to be transmitted, okay, and after transmission at certain point we are going to transmit, and those points are nothing but the speakers, okay, so there is a link between the microphone, okay, to the speakers. Yeah, transmission. Okay, so this is how the acoustics can be defined. Okay, so now coming to the reverberation. Okay, reverberation is very important concept. Okay, so in previous science lessons, okay, you might have heard the term echo. Okay, so basically one should understand what is the basic difference between reverberation and echo. Okay, then and then only you could be able to understand the reverberation definition. Okay, so what do you mean by echo then? An echo is a single reflection of a sound wave off distant surface. Okay, what is an echo? An echo is a single reflection of sound wave of a distant surface. Okay, while reverberation is reflection of sound waves created by the superposition of such echoes. Okay, so I guess I must show you the diagram. Okay, so before that, we will see the more detail about the reverberation. Okay, so basically, okay, let us draw the diagram first, then and then only I could be able to explain you the exact definition of the reverberation. So consider a specific enclosed area where you are having a loudspeaker over here, and here is the source. Let us call it as P, and these are the sound waves coming. Okay. Then, sorry, sound can travel in any direction. Am I right? So we will just considering some of the paths. Okay, the sound travel. Now let me choose another color. Okay. Now the thing is that if you look over here at point P, there is a source. Okay, and this source is listening to the speaker. Okay, and the sound waves from the speaker, okay, are coming in various directions. Okay, they strikes on the wall of the enclosed area and reflected to this source, sorry, to this listener P. Okay, so in this figure, the loudspeaker is the source of a sound, and the person P receives the sound waves directly coming from the loudspeaker, as well as the sound reflected from the walls, ceilings, and floor. Okay, because it is basically a three-dimensional, you know, sorry, uh, let me draw this. So here, suppose there is a speaker, and here there is a listener. Okay, so sound waves are coming to the listener from various sources. Okay, it is directly coming to the listener. Okay, then some waves are hitting to the ceiling and coming back. Some waves are again striking to the wall, then coming back, some waves striking on the floor, then coming back, and so on. So there could be all possible, travel of sound within the enclosure and their reflections. Okay, so now the thing is, note that the reflected sound wave have to travel a longer distance as compared to the direct sound wave. Okay, so these are the possible ways, okay, to the listener, and this is only the direct path. Okay, and all other waves are taking waves because they are striking on this either floor or the ceiling or the walls and coming back to the listener. Okay, so therefore the reflected waves will always reach to the person after some delay. Okay, so obviously this wave is coming faster and others are delayed, right? So how do we what we can say consider all these parameters to design the reverberation? Okay, so when a person hears a reflected sound, it appears like a distant echo if the time gap between the direct and reflected wave is longer than 60 milliseconds. So here is the thing. Okay, so what did I say? When the person P, this person is listening to the reflected sound, okay, it appears like a distant echo if the time gap between the direct, this one, and reflected, this one, okay, is longer than 60 milliseconds. Okay, and if this delay due to multiple reflections, obviously this delay is less than 60 millisecond, then the effect of echo is to prolong the sound. Okay, the sound will continue to persist even after the source of sound stop producing the sound. Have you got that? The sound will continue to persist means you can get the feel of a sound in spite of the source is producing the sound. Okay, the sound will fade away gradually. Okay, because it is coming from multiple reflections, either from the wall, either from the ceiling, either from the floor, depending upon the size of the room. Okay, I hope you are getting the concept, right? So this is very important. Okay, so we can define a new term, reverberation, as the gradual fading of a continuing echo. Now let us go again with a simple definition. Okay, let me draw again the 3D diagram. Sorry, then you sorry, then you could be able to understand. Okay. Mm, if a person is standing over here on the floor and the speaker is mounted on the wall, okay, this wall, and the thing is that now look here, the direct sound is coming. What happened? Wait, there might be some problem. I'll share I'll share it again. Mm. Okay. Okay. So now you can see over here there are various paths, right? So this path is coming directly, and other sound waves. Suppose this is going to the roof and coming back. Okay, then again coming from the walls and coming from this one. Okay, so what in what sense we have defined the reverberation? Okay, we here we are having the term reverberation as what? Gradual fading of the continuing echo. And what we have said earlier, when that person hears reflected sound appears like a distant echo if the time gap, okay, let us consider the time for this direct wave is t1 and for this reflected is t2. Okay, so if the time gap between these two is longer than 60 millisecond, means t1 sorry t2 minus t1, or if we take the mod of that, if this thing is greater than 60 millisecond, okay, so we can hear the distant echo. Okay, and what is reverberation over here is gradual fading of the continuing echo, because what happens, this wave is getting delayed, this t3 also getting delayed as compared to t1. Let us say at a certain point the source is stopped, okay, then also we could be able to listen to the sound by the reflected waves which are coming from various reflected surfaces. Okay, and after some time they get faded, vanished. Okay, so the reverberation is that thing in which gradual fading of a continuing echo is observed. Okay, so reverberation is not always an unwanted phenomenon. Okay, in some cases the reverberation is required also. Okay, so we will see in which cases the reverberation is required later on. Okay, so as far as reverberation is considered, okay, there is one more thing, one more important thing associated with that is re reverberation time. Okay, so this is the important factor. Okay, so the time taken by sound energy in a room or in an enclosed surface, okay, to reduce its 10 to the power minus 6 times of its initial value, that is 60 dB below its initial value, is known as reverberation time for that enclosed room or hall. What is reverberation time? The time taken by the sound energy, okay, in an enclosed room or enclosed area, okay, to reduce its initial value, okay, by how much times? 60 dB below its initial value. Okay, so there is a sound energy, there is a certain initial value, and it is falling back 60 dB or 10 to the time 10 to the power minus 6 times below the initial value. This is your initial. Okay, and that phenomenon is called as reverberation time. It is the I'll again repeat, it is the time taken by the sound energy, okay, to reduce 60 dB of its initial value, okay, is known as the reverberation time. Okay, so this reverberation time corresponds to the time taken by the sound energy to reduce 1 millionth of its initial value. Okay, so longer reverberation time indicates what? The longer reverberation time indicates what? The echo lasts for a longer duration of time. Okay, if uh, consider the room is quite big, right? So if we consider a Gadima hall, right, the room is quite big enough, and if we are having only one source through which we are listening the sound, okay, and you are sitting somewhere at the midpoint of Gadima auditorium, at that time the direct sound is coming to you, okay, the multiple reflections are also coming to you, right? So if the duration of that particular what we can say echoes lasts for a longer time, then you can say the reverberation time for that particular enclosed surface, that is Gatima hall, is longer one, right? Okay, I hope you are getting the concept. What do you mean by reverberation time? If you get a longer echoes, okay, then there is a longer reverberation time. Okay, now this reverberation time depends on various factors. Okay, so what are the factors on which this reverberation time depends, that we will see. So this reverberation time, capital T, is depending on number one, volume of enclosed structure, right? The second, the surface area. Okay, so these two factors are regarding with what we can say the enclosure within which you are going to taking an experience of the sound, right? The third one is coefficient of absorption of the surface area. So here I'll write down coefficient of absorption of surface area. Okay, so this is the third important parameter. The fourth one is sound velocity, and that remains constant in a particular medium. Okay, and finally the wavelength of sound. Okay, so a reverberation time, if adjusted properly, will improve the acoustics in the room. Okay, so based upon what kind of sound you want to listen, for that for that purpose you need to adjust the reverberation time so that it could give a very nice effect for the listener. Okay, so considering all these factors, okay, so the mathematical expression for this reverberation time could be written as capital T, which is equals to 55.3 into V divided by C into A. Okay, where V is volume of the room, this is speed of sound, okay, and A is total absorption. Okay, now this total absorption A can be written as summation of alpha into S, okay, which is alpha 1 S1 plus alpha 2 S2 plus alpha and Sn. Okay, so I can write down I. So I goes from 1 to n. Okay, so S1 or S is the surfaces like walls, partitions, ceilings, okay, the floor, the carpet, and so on. Okay, and alpha is the corresponding absorption coefficient. Okay, respective absorption coefficient. Okay, and the unit of this one, S into alpha, is Sabine. Okay, also here I must say that this point, this 55.3, and this speed of a sound, what is the speed of a sound over here? Yes, it is 344 meter per second. Okay, so these two are constants. Okay, so you can also write, sorry, something happened over here. Let me take the example of the reverberation. Okay, so basically your reverberation time is the, is t equals to 55, what was the figure, 0.3 divided by 344 volume divided by this absorption. So this is 0.16 V by A. Simple. Okay, understood? So I guess we will take one example. We'll take one example so that the picture will be more clear. Let us go with this one. Is it visible to you? Okay, so reverberation time calculation. Okay, so and this just a minute, I'll enter some of the values on this one. Okay, is it visible now? Okay, so as we have discussed earlier, the formula for reverberation, RT60. RT stands for this one, this point, RT60. That is, at the time of defining the reverberation, what we have said is reverberation time, the time taken by the sound energy in an enclosed area, okay, to reduce 60 dB below its initial value. Okay, is known as the reverberation time for that particular enclosed surface. Okay, so now here RT in red color, the RT is reverberation time, the 60 dB below, right? This 60 is equals to 0.16 Sabine per meter. Okay, right? Okay. So no, sorry, here 0.16, that figure, where that figure comes from, we have seen the earlier formula, T equals to 55.3 into V whole divided by C into A. Okay, C is the sound velocity, so 55.3 you can do on your calculator also. 55.3 divided by 344, that gives me 0.16. Okay, 0.16 is the multiplication factor into V upon A, or here they have given SE, which is basically nothing but the total absorption. Okay, so for the sake of an example, I'll just go with some what we can say, some figure for our consideration. Let us consider that we are having a hall. Okay, and the height of the hall is, let us say, 8 meters. Okay, so the length we will consider 15 meters, and the width we will consider 10 meters. Okay, so now if the coefficient of absorption, okay, for the wall is by default taken as zero point 0.3 over here, the floor is 0.3, ceiling is 0.3, you can also vary this, let us 0.2, this is suppose 0.5. Okay, there are some standard figures for that one. Just for the sake of calculation, we are considering these arbitrary figures. Okay, so here we can get the A average, okay, which is 0.3214. Okay, so this gives me this uh, effective absorption area as E. Am I right? So basically what we are doing is we are multiplying the dimensions with the number of that surfaces into coefficient of absorption. Okay, right? So that gives me this total absorption area. Okay, so right from the four walls, okay, then one floor and one ceiling. Am I right? Okay, so considering the total absorption surface area. Okay, the for the room volume would be, what is the volume? It is 1200, the multiplication of height, length and width, right? So if you put all these values in this equation, okay, in this above equation, we can get the reverberation time as 0.8586 seconds. Have you got that? The thing is, you have to calculate, okay, the coefficient of absorption in a very effective manner. Okay, so let us take, I'll just tell you in what sense you have to calculate. Okay, so in a 3D plot, I hope the figures are visible to you. In 3D plot, what we can think of is this particular is the ceiling, this particular is the floor. Okay, so in that what you have to consider is what surface you are considering. Okay, suppose for example, if I consider a floor, on that floor we can have a carpet. For carpet, absorption coefficient is different. Let us consider the what was the dimensions, 15 into 10 into 8, length, width and height. Okay, now I'm considering the floor. Okay, floor is having what? The floor is having dimensions. This is your length, this is your width, this is your height. Length into width. Okay, 150. This is the floor area. Am I right? Okay. Now, carpet. How many carpets are there? Only one carpet. Then covering all the floor. okay, into the absorption coefficient of carpet. Let us consider it is 2.5, 0.25, 0.25. Okay, so the multiplication of this one gives me the absorption at floor, a floor. In the similar manner, you need to calculate the same for the roof also. Are you getting what I am saying? Right? And for the four walls, right? So every time the things have been given to you. Okay. For example, if the surface is covered with the carpet, then absorption coefficient is given. If the walls are with window open, then absorption coefficient is 1. If there is a thick carpet, then you can take the absorption coefficient as 0.58. If there are curtains, if there are audience, okay, so all these things you need to consider while calculating the reverberation time, and that is included within this A. Okay, so this is what is the reverberation time. Okay, so we must note that there is a difference between distant echoes and reverberation. Now we have understood what is an echo and what is a reverberation, right? So the distant echoes are characterized by a time gap between the finishing instant of original sound and instant of arrival of echo. Okay, so it is a time gap between the finishing instant of the original sound and the instant of arrival of echo. Okay, but in case of reverberation, there is no such time gap. The echoes start arriving well before the instant at which original sound dies out. Okay, so thus reverberation is characterized by continuity of the sound, which are coming continuously from various directions of the reflections. Okay, so distant echoes are irritating and undesirable. Okay, basically they are creating the noise. Okay, but reverberation on other hand, it is quite pleasing, and which could be enhanced, which could be very good for enhancing the sound acoustic quality. Okay, so reverberations are desirable, but echoes are not. Okay, so if reverberation of a room is reduced to zero by covering all the reflecting surfaces with sound absorbing material, then resulting sound would appear to be a lifeless and unnatural sound. Okay, so basically to create the liveliness in the sound, you must have some amount of reverberation. Okay, if you reduce that to zero, then that is unnatural sound. Okay, therefore in order to make the sound live and natural, we have to allow some reverberation to occur. The amount of reverberation allowed to occur in a room is measured in terms of reverberation time, just we have seen over here. Different types of enclosed things like auditorium, TV studios, conference halls, lecture halls have typical values of reverberation time. Okay, so lecture hall, speech recording studio, TV studio, and conference rooms have relatively small reverberation times. So, okay, whenever you are delivering something to the audience, you need not to worry about producing some echoes and artistic effects for that particular thing. Okay, so at that time, your reverberation time should be as small as possible. Okay, but the in a big concert halls, churches, okay, so all the you will find the large value of reverberation time, right? So I guess you have understood. With reference to the purpose, we need to vary the reverberation time so that it could enhance the sound, right? And last, we will see one small factor, that is absorption coefficient, alpha. Okay, a small topic, and we'll stop for today. Okay, so this absorption coefficient is defined as a ratio of energy absorbed by a unit surface area to the total energy received by the unit surface area. Okay, so let me write down: alpha is equal to energy absorbed by unit surface divided by energy received by unit surface. Okay, so alpha we were looking at here. Okay, absorption coefficient, what do you mean by that is energy absorbed by unit surface divided by energy received by unit surface. How much energy it is receiving and how much it is absorbing. Okay, so here we are having energy on numerator and denominator, so we do not have any kind of unit to this absorption coefficient. Okay, it is a coefficient. Okay, so for today we will stop here, and tomorrow again we will continue. Okay, and we will be looking at growth and decay of sound. Okay, so don't miss the lecture, because this unit is very very interesting, and that could be very very important as far as exams are concerned. There are a lot of concepts. Okay, so don't miss any of these lectures for this unit. Okay, so I guess we will stop. If you have any doubt, okay, please do contact me, okay, through WhatsApp, or you can just email me. Okay, so I'll try to cover as many as possible. Okay, and I will upload all the recordings, okay, on YouTube, and I'll share those links within Google Classroom. Okay, so if you have anything, means appreciation, doubts, okay, whatever may be the things, you just tell me, because this feedback is to improve the, the delivery of the lecture as well as delivery of the contents, right? Okay, so thank you for attending this one. Okay, take care and revise the concepts, okay, which have been covered in various video lectures, like mine, like Jagdari sir's, or Piske sir's, or Lande sir's lecture. Okay, so we'll stop here. Thank you very much for attending this one.